Hello, my name is, oh, is this too loud? Oh, okay, let's see. Is this okay? This better? This better? This is better? That's good, right? Okay. So my name is Roman Shaposhnik, as you can see on this slide, and for the start of today's presentation, I actually have a question for all of you. Do you know who was responsible for the lovely music introduction that we've heard? It's like, just raise your hands, raise your hands. Raise your hands, who is the guy in the lovely music introduction? The company at least? Two hands. You know what, it's actually very telling about this whole thing that I'm going to talk to you about today. Because this guy is nobody else but Steve Ballmer, the current CEO of Microsoft, but at the time I think he was like a junior CEO or something, or Droid. In 2001, if I'm not mistaken, maybe in 2000, Microsoft got a wind of a very simple fact, that if you don't actively seed your development community, if you don't actively make your development community thrive, your platform dies. Doesn't matter how active it is today, doesn't matter how successful it is, doesn't matter how well you can deploy on it or you can do anything. If you don't have application developers, you don't have applications. And if you don't have applications, your platform dies. It's as, oh, okay, thank you. It's as simple as that. And with that in mind, let me go to my next slide, which is agenda and also last chance of leaving, because we also have a very lovely tutorial next door dedicated to the new packaging system on Solaris, and I highly recommend it for everybody who wants to package applications on Solaris. But for everybody else who wants to stay and listen on what's cool in Solaris as a development platform, here's what we will be talking about today. So first of all, I'll give you a bit of an introduction. Then I will try to convince you that Solaris is the best development platform, regardless of your deployment plans. As a guy who develops compilers and tools for Solaris, I actually know of some of the customers who do weird stuff. What they do is they develop on Microsoft Windows using Microsoft Visual Studio, and then they deploy on Solaris. Now, I want the same weird stuff, but in the other direction. I want you to develop on Solaris and OpenSolaris, and then deploy on Windows for all I care. If you don't like Solaris for its deployment capabilities, be my guest. Suffer the consequences and deploy on Windows. But develop on Solaris, and I hope I can give you enough reasons to be developing on Solaris today. I will try to talk a little bit about Sun Studio, pretty much because, you know, Sun Studio is the organization within Sun I work for. Sun Studio is a set of compilers and tools. You can think of us as Microsoft Visual Studio for Unix. We're available on Solaris, OpenSolaris, and Linux. Then next guest speaker will be Adrian de Groot from Project KDE. And he will be talking about how Project KDE embraced Solaris as one of the development platforms and all of the issues that they had to go through. And last speaker will be Denis Chernoivanov from Tokarema company. He will be talking about more of a commercial style of development on OpenSolaris, and he will actually touch upon some of the deployment issues as well. So with that in mind, let me actually give you a very quick introduction why this is all so important. Again, as I said, Microsoft got a wind of that change very early in the game, and Solaris, meanwhile, kept bragging about deployment. We used to have like this humongous array of applications available on the platform. Well, guess what? We don't have that anymore. Why? Because, you know what? If you lose developers, there is no substitute. Nobody, I mean, you can pay money, I guess, to ISVs, but then the dynamics changes very much so. The ISV is no longer interested in your platform because it's a shrinking market. So it's a bit of a self-fulfilling prophecy. Once you get into a shrinking market, the ISVs won't do anything for you for free unless your platform is interesting as a development platform. So then they will be developing on it, and chances are they might sell on it as well, because if you develop on a platform, deploying on it is much easier. And a good example of that is actually macOS 10. People are bragging about how macOS 10 made a switch from a Motorola sort of based CPUs to Intel-based CPUs. pretty much in a jiffy. Why? Well, because Steve Jobs was smart enough to keep developing macOS 10 on Intel CPUs, but not releasing it in the wild because he had no hardware to release it. Once Intel was the preferred hardware platform, that change happened very, very quickly in the game. Last thing that I wanted to talk to you about, on this slide at least, is that I actually do have a bit of a problem with this conference's agenda. Here's why. When I look at Linux scene, everything is sort of easy to understand. I understand where my kernel gets developed. I understand where sort of the technology gets developed. And let me give you an example of Ubuntu. Ubuntu grew out of Debian. So all of the technology is still available in Debian and gets developed in Debian. But when the platform is discussed, when the benefits of the platform get discussed, that is the Ubuntu thing. They have their own developer summits, and these are very active. So where's OpenSolaris Developer Summit? I guess it's here. But is it Debian-like summit or Ubuntu-like summit? I think it's a Debian-like summit, and there is nothing wrong with it. It's a perfect thing to have. But I want my Ubuntu Developer Summit, because I want to talk to fellow developers and understand what's their pain points, what are they trying to develop, you know, how they're exploiting the platform, what the platform can give to them so that it becomes even more interesting. But what kind of developers are there? What kind of a developer are you? So by just show of hands, how many of you develop something that's part of the core OpenSolaris or Solaris operating system? You know. Okay. How many of you develop applications, user-level applications, unbundled applications? You know, the applications that I'm supposed to download from some website. Okay, better, much better. But you know what? I want the 90% of you to raise hands when I ask that question, because unbundled applications is exactly what makes platform interesting, and I'll talk about it in the next slide. So developers today are kind of an interesting bunch because they are segmented in a way, but also they have a very common, in my opinion at least, set of interests to be concerned about. So they're segmented by technology. I mean, they use different languages, different tools, different software APIs, different hardware APIs. Segmented by market. I mean, you've got database developers, enterprise, HPC, Web 2.0, you know, a whole bunch of those. But in my opinion, and please correct me if I'm wrong, because I really would like to make this into a very interactive discussion. So, you know, bring on your ideas. In my opinion, here's what all of the developers have in common in 2008. First of all, postmodern software development practices are widespread. What do I mean by it? I had a very lovely chat with a fellow at Google who convinced me that a modern development looks like this. You Google for stuff, you find it, and you tweak it for your own purposes. That's to some extent how it looks like, because most of the even commercial applications, closed source, free applications, are based on open source at least by a degree of 50 to 60%. That's one of the latest Evans research studies. So that mass of open source is there already. All you need to do is take advantage of it. And again, the platform has to help you, because if that source code is hard to get, if it's hard to compile, if it's hard to run on the platform, well, you will turn to another platform. So that's a pretty big issue for the modern developer. So modern developer, in my opinion, has a total disregard for a vendor lock-in. We used to be very focused on this idea that vendors, vendor libraries, vendor languages, vendor development tools will help us get the job done quicker. Well, turns out it's not quite the case anymore. With an open source and open sort of style of development, we're actually becoming much more productive. I remember, you know, times when it was about, you know, Borland versus, Zortek. That was a time when a library from Borland had no chance of being compiled by Zortek compiler. Now it's a bit different. Now we don't actually like when vendors tell us that the library is only compatible with something that the vendor sells or even offers for free. Then the line, again, that's a very interesting point, I think, that the line between software and hardware gets a bit blurry. With an introduction of FPGAs and with the advance of the micro devices, it's an interesting point for a platform, and I'll address it in the next slide, of how do you manage the complexity of the hardware world without going crazy on the software front. Last thing that I want to bring to your attention is that it's all about community software development. I don't know about you guys, but when I develop something, at least for which I don't get paid, even when I get paid for it, I want to be part of a nice team. I want to be part of a nice group of people. I want that group of people to bring not only technology to the table, but also all of the social benefits of being just among your friends. You know, I learn from my fellow developers. They, you know, hopefully learn from me. It's all about community software development. So what do developers want? I have a bunch of stuff on this slide, and you're free to read it. But in my opinion, the only thing that developers really, really want is to get the job done. Because when you sit down and you try to program, you are solving a particular task at hand, and every tool at your disposal, starting from compilers to the tools, to the platform itself, you know, documentation even, community, everything that you have around you is supposed to make you more productive. It's supposed to let you get the job done faster. Another interesting point, again, that I just wanted to quickly go over is that we kind of, again, as developers, we kind of like the result of our work to be something we can feel proud of. I don't, again, it's a human feeling. Most of the time, for me, it's about performance. So I'm a speed freak myself. I like my software to be the fastest one around. I know that some like, you know, the GUI be the slickest one around. But again, regardless of what it is, it's something that you can take pride of as a result of your work. And why is it interesting? Well, it's interesting because to take pride is sometimes not even enough. You want others to appreciate it as well. And that's where the whole, again, community angle of development comes into play, because if you're part of the nice community who can appreciate a brilliant, elegant technical solution, then you are sort of, you're drawn towards implementing that solution instead of implementing a quick hack. And in my opinion, that's exactly what sets Solaris kernel and Linux kernel apart. Don't get me wrong, I actually like Linux kernel very much, and it has a tremendous amount of good things that I can talk about. But as far as sort of technical elegance is concerned, I guess they're just optimizing for a different thing. They have a very, very elegant portions of the kernel, but some stuff in the drivers, I mean, don't even look there, otherwise permanent brain damage will occur, because it's just ugly. Now, kernel is nothing compared to the Linux userland, because at least Linus has a particular focus in mind. He's exactly the same speed freak, so he wants his kernel to be the fastest one around, and that's an understandable goal. He also wants it to run on like a variety of different architectures, and again, that's a very understandable goal. Once you get to the userland, now things get a bit uglier, because in userland, what do you have? You have GNU. Well, these guys just, you know, hopefully there's no Richard Stallman around, but GNU just doesn't have any taste in software development, if you ask me. I'm not talking about all of the projects that they federate. I'm talking about like their core sort of community that still develops herd or, you know, something. GNU libc is the worst piece of userland code I have ever looked at. It's just, again, you are not, and when you work with it, even when you try to work around something, just looking at it doesn't make you want to implement any kind of technical elegance. When I work with Solaris, it kind of just helps me. It helps me stay on my toes. It helps me be sort of more elegant, I guess, in a way. Again, just my feeling, but maybe you can share it. So, platform. As far as any platform is concerned, you always have to talk about two things. First of all, what makes platform possible? Because if the platform is impossible to get, acquire, work with, there is nothing I can even mention that would convince you to consider it as a development platform. So in my opinion, and again, if you see something that you would really like to comment on, please bring your questions during the presentation. It'll be a long presentation, so you're likely to forget, and get out of the context. But I think that, first of all, platform has to be available. So what does it mean? It means that it has to run on the piece of hardware that I own. And in that sense, again, that's my heartfelt belief that virtualization is a kiss of death. You can virtualize all you want, but once you start that slippery slope, you're working with the primary host operating system much more than you're working with the virtualized platform. And all of a sudden, you realize that maybe all of the quirks of the host operating system are not that big of a deal. So maybe you don't really have to have twice the RAM to run that other thing in the VMware. Also, I guess that available means that the platform has to be sort of supported by the zeitgeist of the development community. It has to be out there. I actually remember the times when I was just entering the university when everything used to compile on SunOS. Auto tools, for those of you like old enough, appeared when we had gazillions of Unix systems. And the only Unix system on which auto tools compiled my stuff every single time was SunOS. Everything was kind of iffy. Linux was just making its entrance, and auto tools on Linux were kind of iffy, didn't understand all of the kernel, didn't understand all of the glibc. Now the situation is exactly different. We have auto tools which are compatible 110% with Linux and everything that comes with Linux. And Solaris is an iffier proposition. We can talk all we want about how Solaris is much more standard compliant and how auto tools developers ought to read those standards. But the reality is that once your configure breaks, your platform is not available. At least in my definition, it's not available. So the platform, again, to be possible, has to be approachable. And in that sense, the standards that Solaris pays the most attention to the formal standards are important enough, and I guess they're important for customers in the government sector and really big boys on Wall Street. But the de facto standards, in my opinion, is what makes platform possible. If you don't support de facto standards, if you don't support the latest incarnation of GCC or the latest incarnation of GNOME, your platform is not available even though it's fully POSIX compliant and nobody can take you up on the POSIX compliance test. Now, again, GNU generally sucks, but that's the standard that we have, unfortunately. So the fact that Solaris still comes with its own userland tools makes me happy because it's fully POSIX compliant. But then again, my tar, well, I guess I'm using GNU tar. Why? Well, yeah, I'm sloppy. In that sense, yes, I am. I like my tar to unzip and unzip and do a variety of different things. Is it sloppy? Yes, it is, but we have to support it. It has to run on reasonable hardware, and my toaster too. I mean, that's the whole claim of NetBSD, right? It runs on everything. And it really has to run on everything, because the more hardware you support, the bigger the community that you get from the ground up. If you don't support a particular chunk of hardware, there's your barrier of entrance right there. Now, Linux kernel, in my opinion, is a glorified device driver. And it really is quite apparent when you see how operating systems are now, which are not all that into device driver development themselves, are now using Linux kernel in that very capacity. So I am part of this sort of community of Plan 9 developers. And one of the reasons we use Linux is because we take Linux kernel, we strip everything but the drivers and the Zen away, and then it's just a glorified device driver. I want the same thing to be available on Solaris. I want Solaris to support everything, because that way it kind of gets into anything that cannot afford that level of device driver support. One of the nice things about Solaris being backed by a commercial organization like Sun is that we can deal with vendors. So for those of you who are not familiar with NVIDIA drivers, there is no such thing as a native 64-bit NVIDIA driver for Linux. Why? Well, I guess because nobody bothered to pay NVIDIA to write a native 64-bit, even closed-sourced and proprietary device driver. But we did, and we have one. So that's the kind of involvement that I would like the company to make, so that the core operating system becomes a bit more pervasive. So it also has to, and do you know what DSL is? It's actually damn small Linux. So where's my damn small Solaris? I mean, Solaris OpenSolaris that was released in May is a huge step forward. But still, I get this humongous chunk of code, which I cannot really untangle apart. And it's a real pain. So if there is anybody in community who likes to play with these little thingies that are really, really small and really, really effective, one of the nice projects to have would be to have a damn small Solaris. Because again, that's what makes all those routers based on thrown away 386 hardware possible. The fact that the platform has to have a reasonable desktop, I think I don't even have to talk about that. Now, good news is that OpenSolaris makes most of these points, and I should say pain points, go away. So again, for those of you who are still running something else, go ahead and try it out. I mean, I'm running it on my laptop right now. Now, suppose we have a platform that is possible. So anybody in the world can download the platform and install on a reasonable chunk of hardware. So what's next? Really? So if you can somehow find the name, I will. So is it really the same idea that the damn small Linux? Oh, cool, cool. Okay, good, good, good. Okay, so what makes it? Uh-huh, yeah. I see. Might be. I don't know. Again, if you do that, you are opening a door for Linux. Maybe that's the best way to deal with the situation right now. I don't know. But again, the fact that Plan 9, the operating system that wants to be like as far from Linux as possible, still has to use Linux, tells you something about the pervasiveness of Linux. So basically what we do, we have Linux kernel that's stripped pretty much out of everything except for the device drivers and Zen. So Linux boots into hypervisor mode, becomes a host, and then the Plan 9 just becomes a guest operating system. Actually, we used to use Zen, and there's a distribution based on Zen, but it seems to be that Zen is kind of not going into really this direction where we can use it for exactly the same purpose. So nowadays on Linux, they have a different approach to virtualization, which is based on some of the work that the Rusty Russell did. And it's a different way of virtualizing. So basically, what's the name? KVM, yes, KVM, exactly, yes. So now we're using KVM, and we're actually much happier with the KVM than with Zen, because Zen kind of gets all of the baggage of this enterprise class virtualization with it. And KVM is just quick and dirty virtualization, exactly what we need for a glorified device driver. Okay, so in my opinion, what makes a platform interesting is, again, it has to support not just all of the hardware, but it has to support cool hardware. Because I can tell you my personal story. I just bought a GPS navigator. And lo and behold, it runs Linux. So I can hack it. I mean, it's cool. It's really nice when I can remotely, it has Bluetooth. So what I'm doing right now, I'm trying to connect a keyboard to my GPS. And I already have a media player on my GPS, and I can do a variety of different things. But you know what kind of a subliminal message do I get? I teach myself how Linux on embedded devices works. I get that knowledge very subliminally, because I need to, again, I'm a developer. I need to get the job done. I need to hook up my keyboard with my GPS device. I need to play my movies on my GPS device. But in order to do that, I have to learn how Linux operates on an embedded device. So next time, suppose I drop out of Sun for some reason. If I go and apply for a position of an engineer at an embedded company, hey, I already know at least like 10 to 15% of what Linux on an embedded device looks like. It's that pervasiveness that I talk about, right? It's how you experience the operating system, the platform, without even realizing that you're experiencing it. And these are, in my opinion, strategic decisions. I cannot really say that I would be the one to tell that that's the right thing to do. Not for some, that's for sure. Not even for the community. Maybe community has a different goal in mind. But I'm just telling you, I'm just relating my personal story. That's how I experience Linux. If I had Solaris there, well, my knowledge of Solaris would be much better. Now, my knowledge of Linux is better than it used to be. Community is of paramount importance. Unfortunately for Sun, we've been a closed source company that went open source. If you look at all of the Linux distributors, they didn't even exist before Linux. So when they came into play, when they came into their sort of business segment, they already had the psyche of an open source company. I mean, most of the developers that Red Hat hired were already working on Linux kernel. So it wasn't like they hired developers to work on stuff and then they just decided that this stuff will be Linux. They already hired developers who were working on Linux, and they brought all of this culture with them. I still don't think that OpenSolaris, and especially all of the esoteric portions of the kernel development community, that they have that kind of a culture. And that really, really, really is difficult because it manifests itself on so many different levels. We don't discuss things in the open. I mean, we do that in hallways because that's what we always used to do. I mean, I'm in MPK 16, the guy is in MPK 17. I mean, these buildings on Sun campus. So why do we have to communicate in the open, when we can just drop by each other's office and have a conversation? But we have to. See, the problem is we have to. Otherwise, nobody else in the community has no clue what we're working on. So the next time we release something, they're like, guys, couldn't you tell us earlier? No, we couldn't, because we are used to hallway conversations. So community is an interesting idea when you especially bring a big company like Sun into play. So does corporate backing matter? So do you actually have any opinion? Does corporate backing matter? Or does the corporation, does it have to step away like IBM did from Eclipse? Set up a foundation and declare that whatever foundation does is a foundation's business. It has nothing to do with the business of IBM. So what's your opinion? Anybody has any strong opinion on that subject? I think I understand what you mean, but isn't it like we are trying to solve our own problem at the expense of a community? So we are, again, let's take GNOME as an example. We desperately want to get something into GNOME, so we show up, we drop a bunch of source code on these guys and tell them that's the best source code you've ever seen, so just accept it. I mean, in my opinion, that's exactly what I was referring to when I was trying to explain those closed source development principles that we are sort of still under influence of. Instead of working with the community to begin with, and together maybe coming up with an entirely different solution that would benefit all of the platforms that the community has to care about, what we do, which is reasonable for a closed source company, don't get me wrong, we benefit our own platform. Again, very reasonable thing. But then we kind of go, hey, if we don't merge it upstream, the next time these guys release, we will have to merge again and again and again. So we have to merge now, but it's too late because we haven't consulted with the community to begin with. Okay, yeah, that's a very good idea. That's a very good idea. Yes. So to some extent, I guess and again, that's why I asked you guys. My personal preference, if I had a CEO's hat instead of this one for at least 5 minutes, would be Sun has to hire key developers in most of the communities that we depend on in a critical way. One of such communities would be GNOME, and we are doing tremendous amount of work on that front. I think we're doing pretty good. But others, we are not all that friendly with, as far as I can tell. And again, I absolutely agree that one of the ways is just to have developers who are key people in variety of different open source projects come to work for Sun. We see that happening in the language space, by the way. So, you know, we've got a bunch of Ruby developers that way, but not necessarily in the sort of old established projects, which, by the way, brings me to the next point, that Red Hat used to suffer from the very same syndrome. They used to be this like big corporation that wanted to push stuff upstream, and they had a tremendous backlash with Linux. I mean, Linux just had the hardest time accepting their patches. So for a while, Red Hat kernel was a completely different animal from the kernel that was officially released on kernel.org. Now they mastered that. I mean, now they're actually much better in sort of figuring out how to engage with the community to begin with, and then, you know, push all of their agendas through. So, yeah. Yeah, absolutely. Mm-hmm. Yep, I agree. I agree. Well, again, in my opinion, I like to bring Ubuntu as an example of something that I wouldn't call a technical masterpiece, because it's a run-of-the-mill Linux distribution, if you ask me. But it's a masterpiece in a social sense. When Ubuntu came onto market, the market was already divided, and there was no place for an extra distribution. The market had Red Hat, a very significant player, SUSE, and at that time not even owned by Novell yet. And you know, if you were not into the commercial stuff, you always had Debian, like this free, completely open source, you know, totally compatible with GPL and FSF principles. So it looked like, you know, you had those three, and then you had everybody else who had like, you know, tiny percentage of the market share. Now what Ubuntu did was, again, very simple thing from a technical standpoint, but from a social standpoint, they accomplished a humongous task. They made themselves recognizable as the model for commercial engagement into open source projects. So now, again, I talk to like my fellow developers of majority of open source projects. You know, one of the questions that I ask them, just out of curiosity, is what developer summit is the best for you? Like, which one is the most pleasant one? And they always, again, these days come up with Ubuntu. Why? Because it's sort of, it's optimized for exactly the kind of thing that they care about. It's optimized for them feeling part of a bigger community, instead of them feeling like they are contributing to a corporation that then sells their labor sort of and profits from it, but they don't actually get anything. What's interesting from a social perspective, somehow Shuttleworth made that impression that it's very beneficial for you as a developer to be part of the Ubuntu developers community. I don't think that anybody else, not Red Hat, not Novell, made that impression on people. Yeah, sure, you can go work for Novell or Red Hat, and you'll be very successful there. You'll be an employee of the company, you know, you'll get all the benefits. But as a free software developer not associated with any company, Ubuntu somehow gets perceived as the place to be. It's like the coolest place to be. So if unfortunately, I don't really have a way of pointing my finger of what exactly they did, but some magic that they own or possess or know somehow made people realize that it's the place for them to be. And if we can figure that out and make OpenSolaris the place for the most developers to be, that'll be the happiest world ever. Now, what makes platform interesting? Yeah. Mm-hmm. 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 Yep. Mm-hmm. I think you're making actually a very good point when you mention, excuse me, when you mention a Launchpad, because it seems to me like that is exactly the kind of thing that might make developers consider the community as the one to be joined. And in that respect, it's very interesting to observe how Novell deals with what Ubuntu came up with. So Novell now has this build service that is geared towards you developing not just for the Novell platform, but for all of the Linux distributions out there. So what it does is it basically, you can create an account there, and you have an access to a build farm, you have an access to a package farm, and every time you push changes of, in your project to the build server, you just magically get your packages, delivered to all of the necessary repositories, and it's actually pretty cool. In looking at it, I think that they got that idea that if you can offer something that people can relate to, because again, think of it, before Launchpad, most of the development happened on SourceForge. And SourceForge, yeah, well, it had all those 3 servers in their build farm, and it kind of sucked. It even sucked for the source code management system. Now Ubuntu shows up with Launchpad. Now that's useful. Now SUSE shows up with, or Novell shows up with the build server. That's even more useful. So think about what we can do now that we have network.com. Network.com, if you think of it, is this huge cluster of machines that we are not quite sure what to do with. Maybe that's one of the ideas. Maybe that's how we're supposed to develop OpenSolaris community. So we dedicate a certain percentage of the OpenSolaris sort of development machine time on network.com to the active developers, and they can use it for whatever purposes. Maybe we can even make it so that you are not just developing for OpenSolaris, but if you are developing under certain conditions, your packages get available for anything that you care about. Linux, Windows, OpenSolaris, you name it. So, sorry. Yep. So those ideas, again, if you have something like that, please talk to me, because I would be very interested in communicating them back to the network.com guys. I used to be part of the Sun Studio organization. I mean, organizational-wise, I'm still part of the Sun Studio organization, but now I actually work on the network.com project, trying to figure out, what's the right model there for the developers to benefit from the kind of thing that Sun has, and yet bring something back to Sun. Maybe again, maybe that's one of the ideas. So we have to figure out the interface. We have to figure out, what's the right model. But maybe that's the one. these are the kind of ideas that, in my opinion, make the platform interesting. So if I can go to a customer and tell the customer, again, doesn't matter commercial or non-commercial customer, use OpenSolaris, and if you do that, the interaction with network.com becomes so easy that your application can be deployed anywhere. Linux, Windows, OpenSolaris, we don't care. As long as you're developing an OpenSolaris in a particular zone that we configured for you, you're good. You want to develop on Linux? Absolutely, be our guest. Make sure that your source code is compatible with a bunch of standards that it has to be compatible with. Make sure that your source code can be compiled by a variety of compilers. OpenSolaris gives it for free. So something like that might work. Now, ultimately, although, I guess that development tools and practices is what makes a platform interesting. Because every time I talk to people about Solaris, again, the biggest point that gets kicked around is how stable it is. Frankly, I'm tired of it. You know, I'm not the kind of a guy who measures up with another kind of a guy, you know, using my uptime. It's like just not my thing. I'm not a system administrator, excuse me. I understand that it's important, but it's just not my thing. So let's talk about something that might be useful for developers for a change. So before we do that, however, do you think that being part of a bigger picture would make a platform more interesting? So in this slide, I sort of put everything that Sun has in perspective. We do a variety of different software solutions, but if you run these solutions on Solaris operating system, they're better. If you run your Solaris operating system on this little guy over here, this is a Niagara box, they become even better. If you're using our switching technology, our InfiniBand, that becomes even better. So we, as a vertical company, we offer you a particular vertical stack, but then we'll let you make your choice at every single level of that stack. You don't like what we offer? You have a choice. But what we guarantee is that the stack that we offer is the most optimal one ever. You are not likely to come up with a stack that will beat what we offer. You might not like it because of the business justifications. You know, maybe you have to support Windows infrastructure. But the stack that we offer is the best one around. So do you think that the operating system, a platform that's part of a bigger picture, is somehow better? What's your opinion? Does the fact that Linux runs anywhere, but nowhere in particular, makes Linux somehow less competitive with Solaris? Because again, Solaris runs, you know, on Spark, on x86. There is a port to PowerPC going on, and a bunch of other stuff. But we run best on a particular hardware, the hardware that we make. So is it something interesting about the platform? I think that it kind of is. Because again, ultimately, the project that you develop has to be deployed someplace. And if you can optimize it based on business constraints, if you can go to your chief IT officer and tell the guy, you know what, it's part of a bigger hardware stack, so the cost is known. It's part of a bigger software stack, so the cost is known. The cost of running this stuff is a known quantity. It's not like I'm offering you, you know, the latest and greatest Linux distribution and you go support it. It's all known. You have one single place like Sun to go for a support contract for anything like that. In my opinion, that is something that makes a platform interesting. But again, I'll take your corrections. So what does a developer's daily schedule look like? Well, I guess it looks a bit like this. Well, design, edit, compile, debug, and analyze. So from now on, I'll be going through all of these phases in development, and I will try to convince you that Solaris has something unique, something that no other platform has to offer. If what you see on this slide is trivial, boo, just boo, 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 and I'll go to the next slide. So. That's the question that I have. So the fact that it's highly optimized for a particular chunk of hardware, is it a weakness or is it a benefit? That's an open question. Again, I don't really have an answer. I mean, I have my speculations, but I don't really have an answer. So an interesting trend to note in the hardware industry is that in order to build a system that would be future-proof, and what I mean by that is that you're building a system that has a chance of running on a tomorrow's CPU or a tomorrow's hardware, you have to really get the idea that a serial performance has come to an end. Our CPUs are not getting any faster. And on this slide, what I have is a sort of number of frequency of megahertz and years. You see that we've plateaued somewhere around 2005. I cannot quite see from here. We plateaued. So where's my 10 gigahertz Intel CPU? Where's my 10 gigahertz Spark CPU? Just not available. Reasons, I don't know. What I know is that we are now getting performance in a different package. We are not getting CPUs that are any faster, but we're getting CPUs in large quantities. So a single chip will have many different units of execution or cores that would be pretty slow, 1 gigahertz, 2 gigahertz, basically the old gigahertz number. But we will have 2, 4, 8, 16, you name it. And actually, this box is an interesting example. This is a Niagara box. It has 8 cores, and each core has 8 virtual threads per core. So you basically get 64 virtual threads available on a single CPU. Now, that level of parallelism is not available from anybody in the industry. Is it the fastest box around? Not necessarily. Why am I talking about it? Because it's the only box that lets you test your application today. You buy one of these boxes, you install it in a lab, just one of these boxes, you install it in a lab, you build on it, you run your application on it, and at the end of the presentation, I will actually show you how to do that. And for anybody who wants to play with the box, here is a laptop that you could use. The kind of bottlenecks you realize exist in your application, you wouldn't even dream of figuring out without hardware simulator that can run 64 threads in parallel. One of the coolest things in my life was when I had a chance of laying my hands on a Batoka. This is a Niagara 1. Batoka is a Niagara 2. So Batoka had 4 CPUs. Each of those CPUs was like this one. And it was like 256 virtual threads in one single box. I am a developer of the multimedia application called FFmpeg. So I actually developed a codec, a bunch of codecs, but the codec that I'm mostly actively involved in is a DV codec. So anybody who has a DV camera, like this one, knows that you have to convert DV into something like MPEG-4. DV is different from MPEG-4. So I was very proud of how my DV codec was multi-threaded, always. But I haven't had a chance of really proving it until I got one of these boxes. What I discovered was my codec was perfectly scalable. So it scaled pretty much linearly to the number of CPUs I have in the box. How else could I prove that? I don't know. Another result that I got was that another codec, the name will remain silent for a moment, that claimed to be linearly scalable wasn't scalable at all. So it scaled well to about 4 CPUs, and then it just plateaued. When we figured out what was the reason for that, the reason was actually not obvious at all. The reason was a pretty critical data dependency that they had. And you cannot reason. Multi-threaded programming is so hard that even to get your application do the right thing is hard enough. To prove that your application is scalable, this box is something that you have to have. Now, once you get this box, what kind of an operating system can you install in it? Solaris. Why? Because Linux doesn't scale. Linux doesn't scale to 256. Ubuntu, speaking of Ubuntu, actually makes Linux distribution for exactly this box. This was one of the nice benefits of talking to Shuttleworth directly, and he was one of the first guys who released Ubuntu available on OpenSpark and made it available on Niagara machines. We ran it, it just doesn't work, doesn't scale. Huh? Maybe. I don't know what their commercial plans are, but again, the bits are still in existence, so you can download them. So being part of a bigger picture may be an interesting thing, and especially if you want to make your application future-proof, that is one hell of a box to buy. And again, don't get it from me like, I'm a Sun sales rep, trying to make my sales pitch. I actually remember a time when I had an Alpha box. How do you actually remember Alpha? Anybody had an Alpha experience? Alpha was like the coolest box around. It was screaming people. It's like, now that I think about like DEC and, well, don't get me started. Anyway, so Alpha wasn't a platform of choice. That was obvious by, I would say, 95. And nobody in their right mind would deploy on Alpha because Alpha was dying, frankly. Now, why did the company that I started to work as a software developer still kept 2 Alphas in their lab? Because Alpha was the only available 64-bit CPU around. Yes, we had a bunch of Spark 64-bit CPUs, but these were like, an entire year worth of profit of my Russian company was, wasn't enough to buy these Spark ones. Alphas, they were slower than Sparks, but they were the only 64 bits around. So, at that time, in order to make our applications future-proof, we had to keep Alphas in our lab, test on them, not without any hope of ever deploying. Of course, when the Intel 64-bitness came around, I actually still have a connection in that company. The guys were ecstatic because, Alpha kept them going. They didn't lose their 64-bitness, in this transition. So now they support, Intel 64-bit, AMD 64-bit, Spark 64-bit, no problem. So this is one of those boxes. Again, might not be the ideal box for your application to deploy it on, but for development, it's like the coolest thing around, and I'll show you at the end of the presentation. So, what's cool in OpenSolaris? Well, quite a few things. We have a pretty good scheduler, memory management, ZFS. Oh, ZFS. ZFS is a nice thing, but do you actually know that F in ZFS stands for ZPL? So does it ring a bell with anybody? ZFS, in my opinion, is misunderstood. I mean, everybody treats it as a file system, where it is a file system, but the file system is just one layer of ZFS. ZFS has this ZFS POSIX layer, that's what ZPL stands for, that translates the usual POSIX file operations like open, close, read, write, poll, select, the whole usual bunch, into the ZFS sort of actions. But you have a chance of using ZFS as a raw file system, and you can build your own file system semantics based on the raw functionality that ZFS provides to you without the ZPL layer. Now, where this is particularly important is for databases, because again, Oracle, MySQL, and a bunch of other guys are not interested in going through files. They're interested in going through the block layer pretty much directly. It is also very interesting for any kind of file system research that you can do. Again, I'm coming from Plan 9 community. In Plan 9, everything is a file. It's like mind-boggling how everything is a file. But the file system semantics that you build can go much further than the usual open, close, read, write. And one of the things that I like about ZFS is that it lets you do that. Now, event ports. So do I have to talk about event ports in great details, or are you guys familiar with the concept? OK, cool. So before event ports, you had all sorts of things that could trigger an event in a user-land application. So the I/O that you got from a kernel, from an operating system, was segmented into different types of I/O. So you could have used like poll, select, a bunch of other system calls, and you're getting sort of this non-uniform stream of events coming into your application. Each of these events has to have a single thread associated with it. It has to have its sort of own handler, bunch of other stuff. Now, event ports is you take all of these sources of events and you make them available through a single API. So what can you do now? Basically, your application can dedicate a particular I/O point to a whole variety of different events. You're getting all of the events that you're interested in, regardless of the source these events are coming from. Very, very useful for event loop-based applications, like the stuff that at the same time waits for keyboard input, for something to appear on disk, for network input, and a bunch of other stuff. Previously, for every single one of those actions, you had to have a single thread waiting on I/O. Now all you have to do is you have to declare an event port that would accept all of these events, and you have a single thread taking events out of the event port, figuring out what this event is supposed to be about, and scheduling those events inside your application. Very useful thing. I think Oracle was particularly happy about it because, again, that gave them boost of performance. I'm not, I think I don't remember the number exactly, so I won't be telling you. So edit cycle gets a bit easier with Sun Studio as well. Why? Because we have these. Now, I am still a VI guy. I know most of you are Emacs users, so don't beat me up, but I'm still a VI guy, and something like that doesn't really chime all that well with me. But turns out, yeah? Yes. But something like that chimes very well with the next generation of developers, and especially those, thanks for pointing that out, coming out of the Java field. For some reason, us old-timers, C, C++, Fortran, slowpokes, we expect our VI to be there. The Java guys, the interpreted languages guys, like Ruby guys, Python guys, they expect something like this. Well, the good news is we have NetBeans. Not only that, we have Sun Studio. Sun Studio, if you don't remember anything from today's talk, remember one thing. Sun Studio is Microsoft Visual Studio on steroids, available for Unix. Well, that's what it is. It's actually pretty cool. I mean, it gives you this opportunity to fold your source code, and I can sit for minutes, just playing with it. Pretty cool. So compile cycle on Solaris. If you're using Sun Studio, that can give you pretty significant benefits, but my friends who are supposed to be making their presentations right after mine will talk a bit more about how to use Sun Studio and Solaris to the best possible extent. Now, what can I say? Well, one thing is, how many of you use lint? Not bad. How many of you use locklint? Well, you should, because lint is something that checks the validity of your source code. It basically warns you about potential problems in your source code. Locklint is exactly like that, but it warns you about potential problems in your multi-threaded code. So it might warn you about deadlocks, about trace conditions. It is a static analysis tool, so it has its limitations. But as a static analysis tool, it gets you pretty far. Now, my favorite subject is that Solaris, as a development platform, has a much more stable set of plumbing level tools. So when you compile, it's not the compile cycle that matters, it's what happens next, right? You compiled a bunch of source files, you got a bunch of .os, and then the linker comes into play. Well, turns out that Solaris linker plays much nicer with compilers, especially with C++ compilers, than GCC linker does. And nowadays, again, 2008, we're pretty much on par, but still, for stuff like ComDet, where you have different incarnations of templates being generated from different places, and you need those different incarnations of the same template to be to be collated together. You use ComDet. Well, your linker does anyway. And Solaris's linker supports ComDet to a much higher degree than Linux linker does, which makes it much easier for C++ application developers. And sometimes it's a lifesaver. So I might have a chance of telling you a story about that, but let me go a bit further. Oh yeah, and we have GNU tools available on Solaris as well. So if you're really into sort of GNU development, you can use GCC. Now, let me actually talk a little bit more about why does it matter to have basic libraries part of the core operating system. Long time ago, there was a project called GNU libc, and GNU libc was supposed to be a libc implementation for the GNU operating system, which at the time was supposed to be herd kernel. Well, then in '91, Linux came into play, and they decided, hey, we need a libc library, so let's use GNU libc. Well, see, there was a problem with it. GNU libc, even at that time, already had at least 2 masters to serve. They actually had more, but 2 main masters at that time were Linux kernel and GNU herd kernel. In order to support such a different kernels, they had to put in a pretty significant amount of hacks into GNU libc sources. And here, what I have on my screen is a set of different defines that you can pass to your compiler to make GNU libc behave just a tad differently, just a little bit differently. Now, with GCC, most of these defines get somehow managed. So basically, they have this uber define, which is underscore GCC, and that turns on some of these defines. But if you're picky enough, if you want to be POSIX compliant, or if you want your application to be compliant with a particular standard, like let's say, I don't know, BSD source, right? If you want your application to be portable, for example, or if you want your application to be compatible with C99, ISO C99 source, you have to tweak those flags yourself. And because the GNU libc is not part of the core sort of distribution, it serves a variety of different masters. Every time you try to configure GNU libc with these flags, for some reason it breaks. Why? Because nobody tests it. They hope that it'll work, but it never does. With Solaris, GNU libc is part of the core operating system. So it has a single master to serve. And in that sense, you can be well assured that whenever you need a standard compliance, we've tested it because that's the only thing that we test. We don't have to test this libc on Linux and on BSD and on Windows and Mac OS X. The only kernel that we care about is Solaris kernel. And sometimes it just, again, I had the most weird incarnations of GNU libc misconfigurations ever. So like, for example, I had a case where my application was doing a read system call, right? And the interrupt was delivered to the application. And the read exited with a different sort of error code than it was supposed to be exiting. Why? Because somehow in the middle of auto configuration tools, there was one of these flags. I think it was X open source or something that was specified without specifying POSIX C source. So see, you get a dependency between flags, and you're not quite sure how to manage it. Of course, there is no documentation. So the minute I switched my application to Solaris, it just started to work because everything was exactly like specified in the POSIX standard. Very cool thing for just keeping you productive. I don't want to debug GNU libc. I hate it. I want it to die. I don't want to debug it. I want my application to work. Speaking of compilation with Sun Studio on Solaris, do you guys use asserts in your application? Assertions? Well, I'm sure you do. Do you turn them off when you compile your application for production cycle? I guess you do. Well, most of the people do anyway. Well, we have this nice technology in Solaris called dtrace, with which you don't have to turn your assertions off. Why? Because your assertions got turned off by dtrace. Not only that, later on in a production environment, you can turn those assertions on selectively without affecting the performance of the rest of the application. So here's how it works. If you use, if you use dtrace probes as your assertion mechanism, so basically in place of assertion, you insert dtrace probe that fires and does stuff. What it gets initially translated in, so I have this compiler that compiled my test C code, and then I just disassembled the resulting .o. So what it gets initially translated in is the call, which all of us speed freaks know that is not a good thing. I mean, calls are costly. But then here's what happens. You specify all of the probes, so basically that's a secondary specifications of all of your assertions. And then you compile that with dtrace. So dtrace, it's not just a command that gives you information, it's also a compiler as well. What then dtrace does, it turns that call into a bunch of knobs. So by default, when you start up your application, there is nothing at the call site slowing down your application. All of the assertions get turned off by default just by sheer magic of dtrace. Now, because you can use dtrace to enable this probe, and the probe right here is called test, every time you have something in your application that just misbehaves just a little bit. You don't have to recompile it. You just have to turn on the assertions that you're interested in. None of the application speed gets lost. So debugging on Solaris. Debugging on Solaris is pretty cool. So any of you familiar with KMDB, MDB? Okay, so I have to talk a little bit, at least a little bit about these tools. These are pretty cool tools. Why? Because they are integrated into not only userland, but into the kernel as well. And I had a weird case where I forgot a password for a pretty important server. And the only tool that got me through was KMDB, because KMDB is a kernel debugger that is available by default in Solaris kernel. So if you can master MDB, you can use it not only in your user space code, but in the kernel as well. So what I did, of course, I booted Solaris kernel into KMDB. I knew the function that was looking up the file names. So how to get into a Solaris box that's completely closed. Well, I guess you know that init is supposed to exec something that is supposed to give you login prompt, right? So at some point in the game, there is init that needs to exec sbin login, right? Well, now imagine that you know Solaris kernel, and you do because we have OpenSolaris.org, so you can see what function gets executed when the lookup for the actual file that's named sbin init is invoked. You know the name of the function. So when the function is called, instead of the sbin init, all you pass to it is bin sh. So the function gets called, the file gets looked up, and instead of the actual binary that's sbin init, you get the bin sh, and you get into the Solaris kernel, any Solaris kernel. Maybe I shouldn't be talking about that, I don't know. But the point is, it's very, very useful. It unifies your application in a sense that now you have a single tool that can step through anything that happens within your user level and going into the kernel as well. It's like having a single source of breakpoints. You can have your breakpoint in a user level application. You can have your breakpoint in a Solaris kernel. Again, nothing like that, at least to my knowledge, correct me if I'm wrong, is available on Linux, at least not by default. DBX. DBX is a really nice debugger, and one cool thing that I truly love about it is the fact that it's scriptable. It's fully scriptable. It does a whole bunch of other stuff. Again, one of my favorites is fix and continue. When you debug a complicated application and you know that you forgot to initialize this variable, and that's the problem, and to fix that problem, you have to recompile your application, and that takes 4 hours. So because you forgot the initialization, you have to spend 4 hours doing nothing. Well, DBX can take care of that. So what DBX has is a functionality called fix and continue. So every time you see something that you want to fix in place right there, right away, you fix it. DBX recompiles just one particular source file that source line came from, makes it into a shared object, loads it up into the address space of your application, and relinks all of the pointers into the dynamic linker table so that the new code gets executed instead of the old one. Which, by the way, gave me an idea for a very cool scripting in DBX. Again, DBX is scriptable using Korn shell, which is pretty much like Bash, if you ask me. So here's a bit of my .dbxrc. I have a function called digit. And what this function does, it removes a bunch of temporary files, but then it execs vim, or vi, I use vim. In that single file, all that I am supposed to do is define the function called digit, right here. And then I just exit. So the next thing is my compiler turns that C file into the shared object. Then DBX DL opens that shared object into an address space of my application. The function gets invoked, and not only that, I can pass parameters to it. Then DL close gets called, and the application returns to its normal state. This is incredibly important and useful when you're debugging applications with complicated and convoluted data structures. So if you have like something that doesn't have a built-in logger for it available. So suppose you're debugging something that has a tree in it, right? Now you want to traverse that tree, but there is no built-in procedure called dump tree. Well, what you can do, you can call digit, like I'm doing right here, write a very simple tree traversal procedure that will be executed and that will print all of the results for you. So here's an example of using that scriptability. I invoke dbx on the a.out. I stop in main. I do run. I call digit. Here is a bit of my editing in Vim. What I do in digit here is I just print hello world. I mean, that's all I want to do, just for demonstration purposes. This line actually comes out of the compiler. It warns me about printf not being declared, which I don't care about. But then dbx preloads digit.so into the address space of my application, and lo and behold, hello world gets printed. I'm not sure that GDB is capable of that. Worse yet, somehow Linux dynamic linker is not capable of that. Is it useful? Well, you bet it is. I mean, to imagine the amount of time I saved by using this digit is just mind-boggling. And we also have a nice GUI debugger. So, observability on Solaris. Do you guys know what microstate accounting is? Oh, okay, one. You get a prize, which I don't have, but you do. Microstate accounting is your kernel telling you which states your application is in at every single moment in time. So your application, as far as Solaris or any kernel is concerned, can be in the following 10 states. It can be doing something in the user space, useful work. It can be doing something in the system. Most of the time, it's a system call. It can be doing a trap. So a trap is usually when you don't have a mapping for a virtual address space, and the page has to be brought from a disk. That might cause a trap. Then you basically have a data page fault and text page fault and kernel page fault. User lock, sleep, wait for CPU. Wait for CPU is interesting. Wait for CPU is a latency of your application. So every time you have more threads than CPUs available to you, the threads that can do useful stuff but don't have CPUs to do useful stuff on will be in this state called wait for CPU. So you always know whether your application is exceeding the level of hardware that's available to you, or whether the level of hardware is way beyond the application's needs. And the last one is stopped. So every time you stop your application with the debugger, it'll be in this stop state. Now, what's useful is that you can use this, and again, let me give you a quick example. You can use it by a simple prstat command, and you get this printout, specifying percentage of time the application spends in each state. But what's even better, you can use the tool that we're developing called dlight, Project dlight, that visualizes these results. So what you see right here, you have a demo application from Java installation, from JDK installation, which creates quite a few threads. So the height of the bar is exactly how much threads you've created times 1,000. So for example, right here, you see a cursor. And if you add up all these numbers, you will get 15,000. That means 15 threads are created. Not only that, you get the information in which states the threads are in. So the bottom one, this dark purple one, is the user mode. So that's the useful work that you're interested in. And looking at this graph, the first thing that you notice is that the level of CPU utilization of this application is so small that it doesn't benefit from any kind of CPUs being available to it. The amount of useful work that it has to do is very, very, very small. Basically, all of the threads that this Java application is creating are either in this state, which is asleep on user mode synchronization, or in this state, asleep on conditional variable. By being able to profile your application that way, you can actually get a pretty good understanding of where to optimize very easily. So if you have very little useful work in your application, well, you know that you have to do more. If you have more of user synchronization or waiting for I/O, you might need to invest in a better I/O channels. The information, though, is available from the same source that the command I showed you here gets the information from. This is the microstate accounting that's on by default in Solaris kernel. And again, I'm making these claims, but I'm much more into Solaris development than into Linux development these days. So if something that I say you can correct on a Linux side, please do. I'm really interested. As far as I know, nothing like that is available in a Linux kernel. So you cannot look inside your application and say, well, gee, my application is spending 50-50 in user space and kernel space. Just nothing like that is available, as far as I know. Now, hardware counters. So the picture that you saw right here is a sort of a software utilization pattern. It's how your application utilizes all of the different levels of software or kernel that's available to you. It can be sleeping, it can be executing, it can be waiting for the CPU, it can do a bunch of things. Now, hardware counters is a bit different approach. With hardware counters, your CPU is telling you what the application is doing. Not only that, your CPU is telling what all of the applications that are running on this CPU are doing. So the hardware counters is a set of low-level registers in the CPU. And for each register, you can associate a particular action, like an instruction was executed, increment the register. Or floating point instruction was executed, increment the register. Or cache miss of L1 cache happened, increment the register, and so forth. Then you can read the state of the register and know how many page faults or cache misses occurred in your application. The trouble with hardware counters, which are available in all of the modern CPUs, is the first trouble is the instructions to get that information in and out used to be privileged instructions. I think most of them still are, but again, don't take my word for it. So it has to be managed by the OS kernel. Also, the hardware counters have to be virtualized per process context, because otherwise, imagine a CPU that just executes anything that the operating system schedules onto it. Every time you have a miss, a cache miss, it's not clear which application it's coming from, which user-level process it's coming from. So the operating system has to virtualize the hardware counters the same way it virtualizes all of the other registers available to you in a CPU. And it also has to multiplex virtual counters into physical ones. Why? Because CPUs only implement about 6 tops of the physical hardware counters, but the level of events that these counters can track is about 40, sometimes even 100. So you have to be really selective, but if you want to track more than 6, you have to multiplex the virtual ones onto physical ones. All of the things are handled by a Solaris kernel. None of them is handled by Linux kernel by default. The information that you get from hardware counters is actually pretty interesting, and you get it from 2 different sources. You have libcpc, which is your user-level view into the application. And you also have dtrace, at least in the works. So something like that is supposed to be possible pretty soon. So what do we have here? We have asked dtrace to every time there is a data cache DTLB L1 miss and L2 miss. So basically every time the application has to go to the memory, we are recording the the information that the application had that miss inside of it. Then, of course, this aggregation will get printed, and we will know which applications are good ones and which applications are bad ones, and who is hogging your memory controller. Pretty cool. Again, nothing like that is available in the Linux kernel. But what's even better is that we have a special tool that can visualize the information from hardware counters. And the tool doesn't care which application language you write your application in. So what you see right here, you see a Java application, and you see data cache misses and DTLB, data translation look-aside buffer misses. So you could see that this line of Java code, imagine this is Java code. So the code that was first translated into a bytecode, then dynamically compiled by a JIT compiler, and yet we can track DTLB and data cache misses back to that application pretty accurately. So this Java code does matrix multiplication, and unfortunately, it does matrix multiplication in a wrong order. So instead of instead of going through each element one by one, it jumps. So it goes here, then it goes here, then it goes here, then it goes here, then it goes here again. But what it should have done instead is, here and here, right? So this information is only available to us because we can use hardware counters. And again, I don't know of any other tool that would be able to pinpoint that information to you, except for Valgrind that's available on Linux. But Valgrind is a little bit of a different animal. It is an emulator. Whether you like it or not, it's emulating. So it's not real hardware. And again, if I can get the same information from real hardware, I can pretty much forget about Valgrind altogether. Now, what's also cool is that we have dtrace, and I'm sure that you will get an incredible amount of presentations on dtrace today and tomorrow and the day after tomorrow. The only thing that I particularly like about dtrace is that it's a tremendous useful tool for exposing virtual machines. So nowadays, you don't have your CPU executing your source, sort of your user level applications as we used to. We don't write in C or C++, then translate into machine code, then the CPU executes it. We have virtual machines that execute our intermediate code. So dtrace is the most useful tool for those virtual machines to manifest their states. So the virtual machine can use dtrace to say to the outside world, I'm executing this line of code, or I'm accessing this variable, or I'm getting data from here and putting it there. And again, as I showed to you, dtrace doesn't slow down your application by default because all of these probes get turned into a bunch of knobs. So my favorite example is this one. It's dtrace debugging JavaScript application running inside a Firefox browser. It's the only standalone external debugger for JavaScript application that's known to me. I don't know about you. So what you can do, you can trace your functions. You can see how they are executed, what arguments get passed to them. This is exactly the virtual machine telling you, I'm here, I'm there. Use this information, make predictions, optimize your application. But the important thing is that we have a centralized interface for all of the virtual machines, not just JavaScript, but JVM, or Ruby virtual machine, Python virtual machine, Perl virtual machine, LLVM, any kind of virtual machine to manifest its state to the outside world. That's something that not necessarily gets discussed in context of dtrace, but I think it's a pretty powerful tool. I don't think that I have much time to go over procfs. Suffice it to say that I like it and I don't like it at the same time. On the positive side, we have a bunch of very useful tools that can work with your procfs. So one of these tools is, pfiles, tells you which files are opened by your application. Pmap tells you how the mapping of the virtual address space is laid out. Then pstack is something that is pretty useful, sort of just-in-time debugger, right? For any kind of application, even the running one, you can ask where it is, what the stack of this application looks like at this very moment in time. You don't even have to stop this application. You don't have to attach debugger to it. This information is available to you just through a procfs. Pflags, again, you get the information about the registers, the hardware registers. You get the information about, the state of the application and a bunch of other useful stuff. We have PLDD. We have gcore, which is a pretty cool tool, because if you think about it, you have a running application, and you see that something is not quite right in that application. But the application is so important that you cannot freeze it. You cannot just, attach to it and debug it to your heart's content. But what you can do instead, you can take a core of that application. And again, don't be fooled by the name. The application is not going to core dump. What's going to happen is the core file will be created, but the application will continue to go on. And then you can use this core file with a variety of P tools, in the same way that you would be using the regular PID. So the P flags would work on this core file as well. Now, why I don't like procfs is because it's binary. So it suffers from all of the binary issues like endiness, and you have to have the proper tools to access it. The Linux procfs is much less structured one, but at least I can cat and sed and awk the information from it. So that's like a flip side. But the tools are pretty good. So if you didn't know about the P tools, I highly recommend them in the, for your development cycle. Finally, Solaris has a uniform statistics reporting. So you have a bunch of tools which end in stat. And you can profile the execution or the behavior of your application starting from different levels. So VMstat gives you a very condensed information about your application. So for example, it tells you, like the usage of the CPU in particular state, aggregated across all of the LWPs, all of the threads in your application, tells you about the memory consumption and a bunch of other stuff. Now, once you notice that there is something that you don't quite like about your application, so suppose the application is not spending any time in user mode. For some reason, it's always in the kernel. Then there is something wrong with your application, maybe, or maybe not, but at least you have to find out. MPStat is a bit more precise tool to drill into the compute cycles. So what it does, it tells you what your application spends its time in. So it might be doing cross calls, it might be doing, it might be servicing interrupts and a bunch of other stuff. Again, a very interesting way of, you start with VMstat, you get a course information, then you go into MPstat, and then you go into maybe IOstat if you notice that something is wrong with your IO. Although IO is, in my opinion, not all that useful, but again, for the completeness sake, here it is. We also have CPU stat, which gets the information from the hardware counters. So for example, in this case, what I do, I aggregate external cache references, which would be L2 cache, across everything that's running on my box. Busstat, it's not really what the name suggests. It's much more of a tool for huge SAN servers to monitor the interconnect with. It's not for USB bus or PCI bus, or at least I don't find it useful in those scenarios. And kstat is poor man's sysfs. I actually like Linux approach much better. So Linux has this notion of file system, right? That is your kernel manifesting its state to you using files. And how they do it is much cleaner than using kstat. But again, for completeness sake, here it is. So with that, I think we're pretty much down to our last slide. Does Solaris look interesting to you as a development platform? Well, I guess it does. At least I can really vouch for the fact that most of these tools I used at least once to save at least a day worth of my development time. So if something on this list looks interesting or promising, talk to me after the presentation. I can provide more information. Otherwise, make sure that you stay all the way to the end of the presentation, because I'll be demoing the Niagara box. And I'll be showing you the FFmpeg converting DV video into MPEG-4, I think, and a bunch of other stuff. And again, you will see the profile of the applications and how you can make sure that the application is utilizing all of the hardware resources that's available in it. It's pretty loud, so that's why I'm keeping it to the end of the presentation so that we don't distract anybody and don't get deaf. So that's it. Thank you. Any questions? OK, so I guess we're supposed to have a short break for about 5 or so minutes. And then the next presenter will be Adrian. Yes? Mm-hmm.